Welcome to the Preventing Unauthorized Exposure of Confidential Data module of the Symantec Data Loss Prevention 15.5 Administration course. Symantec Data Loss Prevention, or DLP, is the cornerstone of your data protection program. Symantec DLP policies reflect the risk appetite and protection needs of your organization, and based on these criteria, you can identify where confidential information resides, who is handling it, and how data normally flows in your organization. Even before you enable any of the protection mechanisms covered in this lesson, your organization can benefit from the knowledge and visibility that Symantec DLP provides, helping you define how to change broken business practices and drive change in end-user behavior. Organizations can be more successful in the overall program when users are educated in the data protection program. A sponsored incident response team exists, policies are tuned to maximize their efficiency with minimal false positives, and data owners are involved. All those organizational efforts are supported by a wide variety of out-of-the-box and customized options that Symantec DLP provides to protect confidential information from accidental or intentional exposure. This lesson outlines the technology that Symantec DLP offers to organizations for protecting their data in motion, data at rest, and data in use with real-time and on-demand data loss prevention. The business objective for this module is to prevent unauthorized exposure of confidential data, and we'll be covering the following topics: using response rules to prevent the exposure of confidential data, and then how to protect confidential data in motion, protecting confidential data in use, and protecting confidential data at rest. Using response rules to prevent the exposure of confidential data. In this topic, we'll be discussing the different types of Symantec DLP response rules that can be used to prevent the unauthorized exposure of data. Symantec DLP provides several mechanisms that take action to prevent the exposure of data when a policy violation occurs. Those components are called response rules and are available for data in motion, data at rest, and data in use. Symantec DLP performs protection actions using response rules, which dictate what to do when an incident is detected. Response rules enable your organization to prevent and respond to data loss incidents appropriately. These rules are an integral part of all the prevention methods, whether data in motion, data at rest, or data in use. There are two types of response rules, automated and smart responses. The system performs automated responses when it evaluates incidents. Such response rules can be based on a set of conditions, such as agent connection status, incident type, match count, protocol, or severity. These types of actions can be performed by detection servers, whether on-premise or in the cloud, and endpoint agents. In the context of real-time protection, automated responses are available for all three categories of data: data in motion, data in use, and data at rest. Smart responses are ideal for situations that require human remediation and are therefore manually invoked by the incident responder and then executed by the enforced platform. A great benefit of smart responses is that an organization can respond to incidents based on detailed information and context provided by the incident snapshot. Smart responses are available for every type of data loss incident, but are especially useful for actively protecting data at rest. For instance, an incident responder can trigger an on-demand smart response rule to move multiple files with confidential information to a secure location. The general process to create a response rule through the Enforce web UI is as follows. Navigate to Manage, Policy, Response Rule, and then click Add Response Rule. And based on your needs, then choose Automated Response or Smart Response. We will be explaining in detail how to configure each type of response rule later in this lesson. Response rule conditions are optional response rule components. Conditions define how and when the system triggers response rule actions. Conditions provide multiple ways to prioritize incoming incidents to focus remediation efforts and take appropriate responses. The response rule condition options are as follows. First, endpoint location. That is, whether an endpoint is on or off the corporate network. Note that this condition only works for the agent-based response rules of endpoint block, endpoint notify, and endpoint user cancel. Secondly, an event occurs on a configured endpoint device. Note that endpoint devices must be previously defined before this condition can be used. Third, the incident type that has been created. Discover, endpoint, network, or cloud applications and API appliance. Fourth, whether the specified match count has been reached. Fifth, which protocol or endpoint destination matches. And this includes all protocols and endpoint destinations, such as removable storage or CD or DVD. Lastly, severity of the incident. High, medium, low, or informational. For instance, you can create a policy that prevents users from copying information to USB using the protocol or endpoint destination, and set it for a specific number of records using match count, when the endpoint is not connected to the corporate network using endpoint location, and assigning a high severity to those incidents. Symantec DLP executes response rule actions according to a system-defined priority order, and you cannot modify the order of execution among response rules of different types. In all cases, when a server executes 2 or more different response rules for the same policy, the higher priority response action takes precedence. Consider the following examples. In example 1, one response rule lets a user cancel an attempted file copy, while another rule blocks the attempt. The result will be the detection server will block the file copy. Example 2, one response rule action copies a file, and another action quarantines it. The result is the detection server will quarantine the file. Thirdly, one response rule action modifies the content of an email message, and another action blocks the transmission. The result here will be that the detection server blocks the email transmission. You cannot change the priority execution order for different response rule action types. However, it is possible to modify the order of execution for the same type of response rule action with conflicting instructions. For example, consider a scenario where you include 2 response rules in a policy. Each response rule implements a limit incident data retention action. One action discards all attachments, and the other action discards only those attachments that are not violations. In this case, when the policy is violated, the detection server looks to the response rule order priority to determine which action takes precedence, and this type of ordering is configurable. By default, the system sorts the list of response rules, which can be found in the Manage Policy Response Rule menu in the Enforce UI, by the order column in descending order from highest priority, 1, to the lowest. Initially, the system orders the response rules in the order they are created. This figure shown here lists the execution priority of response rules from highest to lowest. To review, Symantec DLP protects information by means of response rules, which can be either automatically executed or manually triggered by incident responders, using automated or smart response rules. Automated response rules can be executed based on several criteria: endpoint location, endpoint device, incident type or severity, match count, and protocol or endpoint destination. And there is a system-defined priority execution order for response rules that cannot be modified. However, it is possible to modify the execution order of multiple response rule actions of the same type. Protecting confidential data in motion. In this topic, we'll discuss how to use Symantec DLP's network and cloud service modules to protect data in motion when using email, the web, or cloud applications. This topic addresses how Symantec DLP protects confidential data in motion in today's environments, where businesses and organizations are increasingly turning to the cloud, or bring your own device, BYOD, and the Internet of Things, IoT, as legitimate means to increase productivity and innovation. For instance, according to a recent study conducted by the Wall Street Journal Custom Studios, 2/3 of global executives now have a cloud strategy in place within their organization. As such, data protection policies have to be enforced in a hyper-connected ecosystem, with information traveling across network infrastructure and devices that do not belong to your organization, and with multiple international mandates and regulations. As shown in this study, the cloud is an environment where users are prone to engage in behaviors that end up placing corporate data at significant risk of security breach. Symantec DLP allows organizations to embrace the benefits of the cloud while protecting information assets by interacting with network architecture components, specifically mail transfer agents and web proxies, as well as integrating with other Symantec solutions such as its CASB, CloudSOC, and information-centric encryption to offer real-time protection for data in motion. Protecting confidential data in motion via email traffic. In order to protect confidential data in motion through email traffic, we need to understand the use cases for ensuring that confidential data does not leave the organization through the improper use of email. This figure here lists some examples that Symantec DLP offers for protecting data in motion flowing through email. This can include encryption, quarantine, or blocking the email entirely and then notifying the sender and the manager. There are 3 additional data in motion protection actions available when interacting with a web proxy and Network Prevent for web. The Block FTP request action blocks FTP requests that contain confidential data or significant metadata as defined by your policies. Through the Block HTTP or HTTPS action, You can block HTTP or HTTPS transactions and display a customized block message in the web client. The Remove HTTP or HTTPS Content Response rule lets you remove confidential content from an HTTP or HTTPS transaction. Symantec DLP has several out-of-the-box response rules for protecting data in motion. For email and MTA integration, Symantec DLP has two options for preventing data loss. The Block SMTP message response rule blocks email messages that contain confidential data or significant metadata as defined by your policies. You can configure Symantec DLP to block the message by returning a permanent delivery error, or send a customized permanent delivery error message to the sender, or redirect the original message to another destination. The redirect feature is typically used to reroute messages to the address of a mailbox or mail list. Administrators and managers can use the mailbox or list to review and release messages. Such mailboxes are outside the Symantec DLP system. The Modify SMTP message response rule modifies email messages that contain the same confidential data or significant metadata. You can use this action to modify the message subject or add specific RFC 2822 message headers to trigger further downstream processing or rerouting, such as message encryption, message quarantine, or message archiving. The real-time protection actions covered in this section are available with Network Prevent for email, Cloud Services for email, and Cloud Prevent for Office 365, in conjunction with a mail transfer agent, for instance, Symantec Messaging Gateway or Symantec Email Security.cloud. Integrating the Symantec DLP detection server with the MTA is the first step in the process of protecting email. Symantec DLP is compatible with a wide range of enterprise-grade third-party SMTP-compliant MTAs and hosted email services that meet the following requirements. The MTA or hosted email service must be capable of strict SMTP compliance. It must be able to send and receive mail using only the following command verbs: HELO, RCPT2, mail from, quit, no op, and data. When running the Network Prevent for email server in reflecting mode, the upstream MTA must be able to route messages to the Network Prevent for email server once and only once for each message. The MTA integration process and requirements are covered in detail in the Symantec Data Loss Prevention MTA Integration Guide for Network Prevent for email. If you are using the Cloud Service for Email set of services, consult the Symantec Data Loss Prevention Cloud Service for Email Implementation Guide. You can use Symantec DLP to protect confidential data in motion by immediately blocking the delivery of email messages that violate a policy. The detection server blocks messages by returning an SMTP-5XX failure response code. The process to create a block SMTP response rule is shown in this figure, and it applies to Network Prevent for email, which integrates with most eSMTP-compliant MTAs, as well as to Cloud Service for email and Cloud Prevent for email, which integrates with Symantec Email Security.cloud. On the Response Rules Management page in the Enforce Administration console, found through Manage, Policy, Response Rule, choose the Automated Response option and select the Block SMTP Message action under Network Prevent. Then click Add Action. The Block SMTP Message action provides two configuration options shown in this figure. Bounce Message to Sender option enables you to specify the text to include in the MTA's delivery status notification, which goes out to the recipient announcing that the email was blocked. If you wish to suppress the MTA's failure notification, leave this field blank. Redirect message to this address allows you to redirect blocked messages to a particular address, such as the Symantec DLP administrator. If you desire to do so, enter that address in this field. If you leave the field blank, the bounced message goes to the sender only. Note that it is mandatory to choose at least one of these options. When creating a response rule that includes the block SMTP message action, there are two ways to configure the method by which the email sender is notified of the block. The first option, for the MTA-generated delivery status notification, you can specify that a customized non-delivery report be sent back to the message sender when a message is blocked. The non-delivery report, or bounced message, contains whatever text you specify in the response rule. The report is generated by the MTA at the moment the message is blocked. This figure shows a configuration in which Symantec DLP relies on the MTA to send a failure notification to the sender. The text included in the bounced message to sender field is displayed in the failure notification. In addition, the original message is redirected to the indicated address. The second option for informing an email sender of a block is to use enforce-generated email notifications. If you want to use the Symantec-generated sender notification to notify the sender of the email block, Symantec recommends that you first suppress the MTA-generated non-delivery report. To do this, leave the bounce message to sender field blank in the block SMTP message response action. Next, add a send email notification action to the same response rule that includes the block SMTP message action. This configuration causes Symantec DLP to suppress the MTA-generated notification and send your customized notification from the enforce server instead. As shown in this figure, the Symantec email notification provides more customization options than the standard MTA delivery status notification, because you can customize the subject and body to a much greater extent, including using variables pertaining to the incident, such as the blocked email subject, recipients, incident ID, and so on. It should be mentioned that there is also a third option, to not send any notification at all. That is, suppress the MTA-generated notification and forego the enforce-generated notification. However, Symantec does not generally recommend that you block email without notifying the sender. In the context of Symantec DLP, modifying the email does not refer to the email body text or attachments. Instead, it refers to modifying the subject heading or adding an RFC 2822 compliant message header to the email, always for the purpose of rerouting or for triggering further downstream processing. These modifications can be leveraged by MTAs to perform several actions based on the intelligence provided by DLP. The process to enable the Modify SMTP message response is depicted in the following figure. Integrate Symantec DLP with the MTA, create a response rule that includes Modify SMTP message action, add a response rule to the inactive policy, then configure downstream MTA to perform actions based on the DLP modifications. To configure Symantec DLP to modify emails for further processing, create a modifying response rule and add it to the appropriate policy. Navigate to the Add Response Rule page, and under Network Prevent, select Modify SMTP Message, and then click Add Action. The Modify SMTP Message action provides two configuration options. To modify the subject, type the text to add to the subject and specify how to add it, prepending, appending, or replace with. Note that the Don't Modify option is used if you only want to add headers without modifying the email subject line. To modify the headers, type the name and value for each header to add to the email. Email Encryption and Email Quarantine Connect, which will both be explained later, are two use cases based on this response rule. This figure shows an example response rule that tells the Network Prevent for Email server to add a header to the email with an XPGP redirect name and a yes value. The name and value you type in the response rule must match the name and value expected by the MTA. When the MTA reads the header, it routes the email to the Symantec Gateway Email Encryption Gateway. Headers can also be used to reroute emails to a quarantine or to an archive. Email encryption is a very effective and mature technology that provides several means for protecting email communications. For instance, by protecting information while in transit through TLS, ensuring messaging integrity through digital signatures, providing password-protected email contents, or providing a secure location to store and read emails. The metadata added by Symantec DLP through the Modify SMTP message action dictates the way encryption and MTA gateways should process the email. This is true whether you are using Network Prevent for email to protect email that originates on premises, or Cloud Service for email to protect email that originates from supported cloud email applications. Symantec technology provides a comprehensive coverage for email encryption, whether on-premise or in the cloud. For Cloud Service for email, you can use Symantec Information-Centric Encryption, or ICE, to encrypt email from supported cloud email applications, such as Office 365 Exchange Online or Google G Suite Gmail. This figure here shows how to configure the response action to encrypt cloud email with ICE. Symantec DLP Network Prevent for email can be integrated with most any encryption gateway, including with Symantec Gateway Email Encryption, formerly called PGP. This figure here shows how the encryption process occurs. First, outbound email is received by the MTA and then sent to Symantec Network Prevent for email. Then the email content is checked for policy violations. If a violation is detected, an incident is created and the Modify SMTP rule will add the headers properly. Then the email is rerouted to the encryption server, where the email is encrypted and sent out again. Finally, the remediation status is updated with confirmation messages sent from Symantec Gateway email encryption. Email Quarantine Connect is an integration between Symantec DLP and Symantec Messaging Gateway that relies on the Modify SMTP message response rule. The integration is intended for a workflow where Symantec DLP applies detection policies to email messages and sends suspect messages to Symantec Messaging Gateway, where they are quarantined pending further remediation. Administrators can trigger the defined actions from either platform. Using the Symantec DLP Enforce console, you can initiate remediation actions such as releasing the message from quarantine, deleting the message, encrypting the message, or performing other actions. Users can also initiate those remediation actions from the Symantec Messaging Gateway Control Center. Regardless of the platform where the remediation is performed, the incident details are updated on both platforms with messages about the remediation. Protecting confidential data in motion via web traffic. Working in conjunction with network proxies, Symantec DLP Network Prevent for Web can protect you from the loss of confidential data in motion by blocking the transmission of HTTP, HTTPS, and FTP content using the Internet Content Adaptation Protocol, or ICAP, as well as its secure version, SICAP. Some examples of use cases can be found in this figure: content removal for social media, sanction use of webmail, and protecting bulk data transfers. There are 3 additional data in motion protection actions available when interacting with a web proxy and Network Prevent for Web. The Block FTP request action blocks FTP requests that contain confidential data or significant metadata as defined by your policy. Through the Block HTTP or HTTPS action, you can block HTTPS transactions and display a customized block message in the web client. The Remove HTTP or HTTPS content response rule lets you remove confidential content from an HTTP or HTTPS transaction. As shown in this figure, the integration with a web proxy is the first step in the process to configure web protection. The current list of supported proxies is maintained in the Symantec DLP System Requirements Guide, which is available at the public Symantec Technical Support page at support.symantec.com. To configure Symantec DLP to block HTTP or HTTPS requests, create a blocking response rule and add it to the desired policy. To create the response rule, navigate to the Add Response Rule page, and under Network, select Block HTTP, HTTPS, and click Add Action. Type the text to send to the HTTP or HTTPS client, as shown in this figure. For example, you may include some HTML coded text to display in a browser. But note that if the requesting client is not expecting an HTML response, the rejection message may not be displayed in the client's browser. For example, a client expecting an XML response to a web post may only indicate a JavaScript error. Lastly, to block FTP communications, creating the response rule is very simple because there is no configuration beyond adding the action to the response rule, as shown in this figure. The Remove HTTP or HTTPS content response action lets you remove confidential data from web posts and from web-based email messages, and notify the user or the web email recipient that data has been removed. For web-based email messages, for example, confidential content can be removed from the email body as well as from attachments. This response action works for HTTP, HTTPS post requests, such as posting to a blog site, or attaching a file to a web email message, or sending a web email message. Note that this response action removes all content from a post or email, no matter how much of the content is actually matched against your policies. The Remove HTTP, HTTPS content action does not interfere with user search engine queries, Google searches for instance, because Symantec DLP does not remove content from GET requests. If it is not possible to remove content from the web transaction, Symantec DLP executes a fallback option that you can specify. The choices are Block, the default, or Allow. This figure illustrates the configuration settings for this response rule. Parameters for supported websites are defined and can be found in the protect config http://redaction.cfg file. This diagram conceptualizes what the flow of traffic from an end user through to the internet looks like once the service has been networked and policies have been rolled out. The user will initiate a web request, and the browser will route the request to the web proxy. The proxy forwards the request via ICAP to Network Prevent server for inspection, and Network Prevent responds with a verdict of detection analysis. If the request triggers a policy that has blocking response actions, the proxy will block the request and optionally return a block page to the user. Or if no policy match or no response action was found, Network Prevent ICAP response tells the proxy to let the request go through. Protecting confidential data in motion to cloud applications. This topic takes a brief look at how DLP policy can be applied to data in motion through cloud applications by integrating with another Symantec product, CloudSOC, through the use of Cloud Detection Service. CloudSOC is Symantec's Cloud Access Security Broker, or CASB, solution. Part of the remit of the solution is to ensure that due diligence, oversight, and security can be applied to the use of Internet repositories, collaboration sites, and others, whether they are approved corporate repositories or not, and regardless of whether the device making the connection is customer managed. The integration of CloudSOC with Symantec DLP allows the extension of DLP policy to apply to all applications that CloudSOC supports, for both data in motion, using what CloudSOC calls gatelets, or data at rest, using securelets. This significantly expands the field of visibility available to the DLP team in terms of what is stored and where and with whom it is shared. It further allows the team to ensure that data in motion to, or at rest on, those applications complies with DLP policy, and if not, that action can be taken and reported back to the Enforce console. This figure lists some of the use cases that Symantec DLP offers for protecting data in motion that flows to and from supported cloud applications. These use cases are extending existing DLP policy to cloud applications which have document sharing, collaboration, or storage facilities, applying policies to accounts that are corporate or personal, and monitoring the content of data while it is in motion and taking action on it. Please note that we'll discuss how CloudSOC protects data at rest later in this lesson. Here are some of the CloudSOC response rules applicable for data in motion: blocking data in motion, redacting data in motion, or doing a custom action on data in motion through the use of JSON. The actions covered in this section are available for all supported cloud applications as well as the API appliance. The process for integrating CloudSOC with DLP is detailed more comprehensively in the upcoming Enhancing Data Loss Prevention with Integrations lesson. The Cloud Detection Service is the cornerstone in ensuring that CloudSOC is able to know what DLP policies to look for and be able to receive feedback incident data. Cloud Detection Service is a prerequisite to integrating DLP policy with CloudSOC's ability to inspect data in motion to or residing on cloud applications. In addition to CloudSOC, Cloud Detection Service integrates with other cloud services such as Symantec Web Security Service, or WSS. These services let you protect confidential data residing in supported cloud apps or being transmitted to or from cloud apps or the larger internet. This diagram shows the four main areas for setting up a cloud detection environment: implementing Symantec DLP Cloud Detection Service, configuring Enforce, and then configuring the client-side browsers to ensure that web traffic to all cloud apps passes to CloudSOC. In order to create policies that apply to CloudSOC, the system must have both a license for CloudSOC and a license for Cloud Detection Service. At that point, you can integrate DLP with CloudSOC within the CloudSOC user interface. From that interface, you can activate gatelets, the monitors of data in motion for specific brands or services for which you wish to enable data scanning. Once a gatelet has been activated in CloudSOC, and the user machines have the specified application traffic being redirected to CloudSOC, there are a number of steps that the administrator must take in Enforce before a DLP policy can be applied to the data in motion. The first two steps are standard for all DLP products. The third step, however, will be specific to the CloudSOC integration. First, create one or more response rules. Ensure that the rule name and the description field are relevant to the task. Optionally, you can click Add Condition. In the Incident Type field, you will find an option for when this response rule ought to trigger, which relates specifically to cloud applications and API appliance. Next, select the actions you want to apply to cloud applications and API appliance data in motion. Most of these options are either on or off. However, if you are using a custom action or have a quarantine service, there is also a custom payload to include in the configuration of the rule. If you are using Symantec Information-Centric Encryption, ICE, to encrypt, select the Encrypt Data in Motion response action and leave the text box blank. Note that using ICE encryption response action requires the integration of ICE with CloudSOC. For more information on this integration, please see the Symantec ICE and the Symantec CloudSOC product documentation. Given the nature of the data being examined, and in view of the fact that it is possible to configure policy on data at rest, with more discussion on this later in the lesson, it is a best practice to avoid creating any smart responses for data in motion, as the end user will be severely impacted while administrator investigates. After you apply the response rule to the policy, you will need to create an application detection configuration. To do so, from the Type drop-down, select Gatelet, and for Applications, specify whether to apply the policy to any or selective applications. Then apply the configuration to Policy Groups. Select the rules you want to apply to the configuration. These rules will look at transfer type, meaning uploads, downloads, or both, device properties, whether any, managed, or unmanaged, users and groups, and regions and file properties. These rules effectively tell CloudSOC the conditions under which traffic should be sent to the Cloud Detection Service for review against policy. Further, it is important to note that this inspection can be applied to traffic which is being both uploaded and downloaded. If the gatelet is also supported as a securelet, it would be advised not to inspect downloaded content, as the data can be protected without impacting the user experience when action is taken on the data at rest. When a securelet cannot cover this use case, use caution in the actions taken in the responses. Policies with response rules to encrypt matching content, if applied to a download, will impact the user's experience. Indeed, it is considered best practice in this instance to ensure that gatelets have separate configurations for uploaded and downloaded traffic to avoid this situation from occurring. Additional controls for when the gatelet should refer traffic to the Cloud Detection Service can include device properties, meaning is the traffic to the gatelet coming from a managed or unmanaged device? Is it a corporate or personal device? And is it compliant or not? Depending on the answers to these three questions, you can opt to have traffic from the device monitored or not. The next few options allow you to configure the application detection by inclusion or exclusion. Mark any to target all available options for inspection, or optionally configure an all except policy by making use of the add exceptions function if appropriate. Use selective to target specific traffic for inspection, and this can be filtered by users and groups, regions, and file properties. You can create one or multiple configurations per gatelet depending on whether there is greater granularity required, based on user location, for instance. Equally, you could opt for a blanket configuration which covers all gatelets for all users. Once configuration of the response rules and application detection configuration is complete, Enforce pushes out the required information to the Cloud Detection Service and CloudSOC infrastructure simultaneously. During the course of normal operation, when CloudSOC receives data which matches the detection configuration, CloudSOC is able to redirect that traffic, together with information about the policy groups to check against, to the Cloud Detection Service, which then examines the content against policy, flags any matches, and then tells CloudSOC which actions to take, if any. Once configuration of the response rules and application detection configuration is complete, Enforce pushes out the required information to the Cloud Detection Service and CloudSOC infrastructure simultaneously. When, during the course of normal operation, CloudSOC receives data which matches the detection configuration, CloudSOC is able to redirect that traffic, together with information about the policy groups to check against, to the Cloud Detection Service, which then examines the content against those policies, flags any matches, and then tells CloudSOC which actions to take, if any. These next two figures illustrate how traffic flows after these steps have been completed. This figure shows the process when a policy to block specific traffic is applied to the application detection configuration. In the first step, the user uploads a file to the cloud application, and the endpoint computer is configured to route cloud application traffic first to CloudSOC. CloudSOC will analyze the traffic against the rules specified in the application detection configuration and finds that the parameters match. Next, CloudSOC forwards the filed contents to the Cloud Detection Service, which detects a violation, creates an incident, and tells CloudSOC which action to take. In this case, CloudSOC will block the file upload, and when configured, notify the end user. By contrast, this figure demonstrates when no match is found, how the transfer will complete as normal. CloudSOC will still forward the traffic to the Cloud Detection Service, but when it does not detect a violation, it tells CloudSOC to allow the traffic through, and the file transfer is permitted as normal. In addition to CloudSOC, Symantec DLP Cloud Detection Service also integrates with Symantec Web Security Service WSS to monitor and block confidential data uploaded over the Internet, over HTTPS and SFTP. Cloud Detection Service returns a recommended response action to WSS when the analyzed data violates DLP policy. For more information about Cloud Detection Service, see the lessons Overview of Symantec Data Loss Prevention, Identifying and Describing Confidential Data, and Enhancing Data Loss Prevention with Integrations of the Symantec DLP Administration course. Note that the block response rules for data in motion can also be applied to WSS. However, regardless of the specific response action you choose, in the current integration, Cloud Detection Service will only deliver a recommendation to WSS. The actual response to be executed must be configured directly in WSS. To review, Symantec DLP helps prevent today's threats to data in motion by integrating with email and web infrastructure, both on-premises and in the cloud. Out of the box, here are some of the actions that Symantec DLP can perform. For data in motion via SMTP traffic, DLP can block SMTP messages by returning an SMTP-5XX failure response code, or it can modify SMTP messages by adding RFC 2822 message headers to trigger further downstream processing or rerouting, such as message encryption. Symantec offers Email Quarantine Connect and email encryption options that rely on the Modify SMTP message action to perform advanced email protection. For data in motion via web traffic, DLP can block FTP requests, block HTTP and HTTPS transactions, and display a customized block message in the web client, or it can remove HTTP or HTTPS content entirely. For data in motion to cloud applications, DLP can block data in motion, blocking any traffic that matches the parameters of the DLP policy, thus ensuring it will not be written to the cloud application. Optionally, a notification can be configured to be displayed to the end user should this occur. DLP can also encrypt data in motion, where DLP, CloudSOC, and Information-Centric Encryption, or ICE, are used together. This combined functionality will ensure that content matching policy will be written to the cloud application now in an encrypted format. Lastly, custom actions on data in motion allows you to create a custom action on matching content if the action you want to take on traffic that matches policy is not available in the list supplied. This might be because functionality has been added to the application that is not yet replicated and enforced, for example. Additional cloud data in motion use cases are available with the integrations among Symantec DLP, Symantec CloudSOC, Information-Centric Encryption, and Symantec WSS. Protecting confidential data in use. In this topic, we'll discuss how to use Symantec's DLP endpoint products to protect data in use. Symantec DLP can help you deploy a data in use protection strategy that is aligned with your business needs, giving you the insight and control necessary to secure confidential data at the endpoint. While information today travels across public and private clouds, internal back-end systems and SaaS providers, and both company-owned and BYOD devices, endpoints continue to be important business resources where employees rely on data in use to help organizations fulfill customer services, embrace the cloud, make strategic decisions, and foster innovation. At the same time, according to Verizon's 2016 Data Breach Investigations Report, removable devices such as USB flash drives continue to be involved in the majority of breaches motivated by malicious insiders. In this scenario, Symantec DLP can protect a wide range of operations that could lead to data loss at the endpoint. Symantec DLP offers several options for addressing the protection of data in use. When a user action involves information protected by a defined policy, such as moving a file to a USB device or to a cloud storage application, Endpoint Prevent creates an incident regardless of whether a response action has been configured. This auditing mode can be critical to successfully understanding how the information is being used before enabling actions that could harm legitimate business processes. Always consult with your legal department and other relevant stakeholders before enabling any audit actions on your users. The figure below covers additional use cases for protection of data in use. Auditing, overseeing how sensitive information is being used and who is using it. Awareness and education, to foster behavioral changes in end users and improve data protection practices. User-driven protection, promoting user-driven data protection with minimal impact to business. and data in use protection, providing real-time protection for highly confidential information. In addition to the silent audit capability provided by Endpoint Prevent, you can also use the out-of-the-box automated response rules specific to Endpoint Prevent for protecting confidential data in use: notify, user cancel, and block. Additionally, DLP is able to integrate with Symantec information-centric encryption. The Endpoint Prevent Notify response rule educates the user about the violation that has occurred, but does not block or stop movement of the data. This rule creates an on-screen notification, such as a pop-up window, that contains information about the violated policy. The user must provide a justification for the action. The Endpoint Prevent User Cancel response rule lets users allow or cancel actions that violate certain policies. In addition, the user must provide a justification for the action. An incident is created no matter which choice is made. The Endpoint Prevent Block response rule stops the movement of data that violates policies. This rule also optionally displays an on-screen notification that contains information about the violated policy. The user is also given an opportunity to provide a justification for the action. The Endpoint Prevent Encrypt response is available to customers of Symantec's Information-Centric Encryption, or ICE solution. If this service is configured in Enforce, then the response option is unlocked, and this has the dual benefit of ensuring that any confidential data that is moved, to portable storage devices for instance, can be permitted, but only if it is encrypted. Additionally, it ensures that the data can only be read on machines capable of decrypting the content, or by non-corporate devices when the user is authenticated. Symantec DLP also provides the Endpoint FlexResponse technology, a flexible platform that allows the creation of customized actions to perform incident remediation, for instance, encrypting a file being copied to a USB device. For the configuration of the on-screen notifications for notify, user cancel, and block actions, there are several shared fields. For language, you can create different endpoint response rule notifications that are specific to the system locale setting in the operating system of the endpoint. When configuring endpoint pop-up messages, you must configure separate notifications for each required language. The agent automatically selects the appropriate notification based on the endpoint system's locale. If a user wants to configure a response rule in a language not supported by the endpoint agent, the administrator can choose Other as the language choice in the endpoint response rule and type the justification labels in the desired language. Endpoint notification pop-ups apply the user's selected display language instead of the language in the system locale. For instance, if the system locale is set to English and the user sets the display language to German, the pop-up appears in German. Additionally, the user must modify the endpoint settings of the endpoint server to type localized labels for the static elements of the pop-up. The display alert box with this message field holds the text of the notification that users will see. The text also can include incident variables, discussed in the next slide, and you can also add hyperlinks to refer users to URLs that contain company security information. It is recommended that the response text be concise and that links be used to point to additional details. If the response text is too large to fit in the text control box of the notification windows, this corresponding text will be truncated in the pop-up, and a tooltip window will be displayed. By inserting variable fields into the pop-up, you can enhance the impact and understanding of data protection policies by including information specific to the incident that triggered the on-screen notification. You can add information about application, content name, content type, device type, policy name, and protocol. One of the most effective controls for preventing data loss is end-user awareness. The Endpoint Prevent Notify response rule is a very efficient mechanism for fostering a culture of data protection by changing user behavior without disrupting business processes. It is important to mention that although the action that triggered the response rule is not prevented or blocked, the incident is still created and sent to the Enforce console. The Allow User to Choose Explanation configuration setting allows you to display up to 4 user justifications in the on-screen notification. When the notification appears on the endpoint, the user is required to choose one of the justifications. If you select Allow User to Enter Text Explanation, the user can enter their own custom justification. Symantec DLP provides 4 default justifications which you can modify or remove as needed. Those are Broken Business Process, False Positive, Manager Approved, User Education, and Custom. The user justification response that the user chooses appears in the incident snapshot and is available for filtering and summarization in the UI. There is 1 notification pop-up per violation, although the end user can select the option to apply the justification to subsequent dialog boxes resulting from the same action. The Endpoint Prevent Block response rule is used to restrict sensitive data from leaving the endpoint. This type of response rule is created in a similar manner to the Endpoint Prevent Notify response rule. The notification message is still fully configurable with 4 optional user justification responses, and the response that the user chooses shows up in the incident snapshot and is available for filtering and summarization in the UI. The difference is that in the resulting action of an Endpoint Prevent Block response rule, the data is stopped from leaving the endpoint. You also have the option to block without notifying the user. To do this, when configuring the Endpoint Block response rule, deselect the option Display Alert Box with this message. After the response rule is added to a policy and a violation occurs against the policy, the user might notice that their file did not copy properly, that their file failed to print, or that they were unable to send their web form. They do not, however, see a pop-up notifying them that their action was in violation of policy and asking for a justification. The Endpoint Prevent User Cancel response rule is useful in situations where the organization trusts a portion of stakeholders to decide whether or not to permit an action that results in a DLP incident. For instance, in a typical scenario where a user is attempting to copy confidential file information to a local USB device, depending on the conditions of the policy, a pop-up message is displayed informing the user of the potential violation. Users are again given the opportunity to select a justification for this action, but now they are also given the option to choose whether to allow or cancel the operation. The end user can choose Allow if the action is acceptable and must be allowed to complete, or Cancel if the action is unintentional and must be canceled. An incident is generated in either case. Any combination of justification and action can be selected. However, it is important to note that selecting a justification does not affect the allow or cancel behavior. For example, if you select the justification, "My manager authorized this transfer," this does not override a selection of cancel. Note that this pop-up message is timed, so the user must select the desired operation before the countdown expires. After the countdown has completed and time has expired, the user can still select an appropriate justification. An Apply All option is displayed that allows the user to apply the selected justification to any subsequent dialog boxes that may be generated as a result of this action. Once the time has expired, the option to choose Allow or Cancel operation is no longer available. The user must then select OK, and the default action is applied to the operation. By default, the rule is set to block, but can be configured to allow if desired. Notice that there are 2 pop-up messages that can be customized to configure the Endpoint Prevent User Cancel response rule, as shown in this screenshot. The first is for the pre-timeout warning message that is displayed while the countdown is active. The second is for the post-timeout warning that is displayed after the countdown has expired. You can integrate DLP with Information-Centric Encryption, or ICE. High-level details on how to integrate these products appear in this figure, but is discussed more comprehensively in the upcoming Enhancing Data Loss Prevention with Integrations lesson of this course. Note that ICE functionality is only available to DLP customers that have also purchased Information-Centric Encryption. Once ICE has been configured, the encryption response rules that appear as options in the portal can be applied as normal by creating a response rule with the Endpoint Prevent Encrypt action. You can also configure pre- and post-timeout messages, the main pop-up notification text, as well as optionally the user justification choices. The language that these notifications will appear in can also be selected. Once saved, the response rules must be added to policy before the actions will be applied. Endpoint FlexResponse lets you create your own response rules for protecting data in use. For instance, you can create an Endpoint FlexResponse rule that automatically assigns digital rights management to a file being copied to a USB device. FlexResponse works both online and offline. It is an application program interface, or API, that lets customers specify actions that leverage other third-party tools in their enterprise, in addition to getting access to pre-built plugins. The endpoint agent can execute Python scripts that contain an embedded engine. The plugin is distributed to agents through a third-party mechanism, such as MSI or SMS. The plugin is then loaded into the agent's memory and can receive specific parameters, including credentials if necessary. Additionally, the data owner can maintain detailed control of the actions taken on one or more incidents. Note that this is a fully automated protect action that occurs after incidents are triggered. The protect actions cannot be performed manually, as is the case with smart responses. In summary, Symantec DLP Endpoint Prevent provides real-time protection against data loss at the endpoint. The notify action does not block, but fosters awareness by informing the user that the intended action involves confidential information. The user cancel response rule empowers certain users to decide whether to stop actions that, despite containing sensitive information, may still be part of a valid business process. Through the blocking action, Endpoint Prevent stops end-user actions according to policy. And the encrypt action ensures continued productivity by ensuring confidential information being transferred to another destination is encrypted first. This means that the data transfer can occur, but that the data can only be accessed on computers which are able to decrypt the content. The Endpoint FlexResponse is a platform that lets customers and partners develop customized actions, such as encryption, digital rights management, and classification. Protecting confidential data at rest. In this topic, we'll discuss how to apply protective actions to information stored in file systems and content repositories. Symantec DLP offers a comprehensive set of options for the protection of data at rest. In any organization, the information that fuels daily operations and long-term sustainability is kept in repositories such as file systems, databases, and content management systems. These repositories are mostly on-premises, but there is a clear tendency towards the adoption of cloud solutions, and these repositories almost always contain confidential information. Massive data breaches have already occurred, either after malicious outsiders have infiltrated such information repositories or due to mistakes and carelessness of information owners and users. Symantec's Internet Security Threat Report, Volume 21, released in 2016, show that during 2015, 48% of data breaches were caused by data accidentally being exposed in corporate repositories. Protecting confidential data at rest residing on premises. Symantec DLP offers effective controls for identifying and protecting data at rest on-premise. These controls can be triggered in real time, immediately after the information has been found, or on demand by the incident handling team. Symantec DLP can help organizations with additional controls, such as encryption, modifying access control lists, and tagging information in the cloud. This figure illustrates some of the common and relevant use cases for protecting data at rest. Symantec DLP helps organizations answer a fundamental question for data loss prevention programs. Where is the data that needs to be protected? Once the organization has identified where the data is, Symantec DLP can apply several controls over the information. This figure displays the actions available for protecting data at rest that is located on-premise and on endpoint computers. It is important to remember that most of these actions can be executed at the moment the incident is detected, through automated response rules, or on demand after an incident responder chooses a course of action, known as smart response rules. The latter option can also be applied to multiple incidents from an incident list report on Enforce. Using Symantec DLP Network Protect, organizations can take protective action on data at rest found on file servers accessible by CIFS and SharePoint servers. For data on file servers, you can automatically copy, quarantine and relocate, or encrypt confidential data. For data on SharePoint servers, you can automatically quarantine or encrypt confidential data. Note that for file servers as well as SharePoint servers, automatic encryption is performed through an integration with Symantec Information-Centric Encryption, or ICE. This figure shows one example of a protective action for data at rest. Network Protect can be configured so that when it identifies a sensitive file that creates a high-severity incident as defined by policy, this file can be removed from the target server and relocated to a more secure and potentially encrypted file share. The quarantine location is fully configurable and is set up in Enforce. The quarantine location maintains a directory structure mirroring the source location to simplify management, which is useful for triaging, but also in case a file needs to be recalled from the quarantine location. When relocating a document, the original file is removed, and Network Protect can optionally leave a marker text file in the original location to explain why and where the file was quarantined. The file copy functionality of Network Protect is also useful for e-discovery collection and for complying with a litigation hold. Configuring Network Protect to take protective action on confidential data requires you to do two things. 1. Create the appropriate response rules and add them to a policy. and 2. Configure the scan target to apply the relevant policies and to execute the actions. To create response rules, in the Enforce console, go to Manage, Policies, Response Rules, and then click Add Response Rule. Select Automated Response, and then click Next. This figure shows an example of how to configure a copy and quarantine response action. For encrypting discovered confidential files in place, you can integrate Network Protect with Symantec ICE. The high-level steps for this integration are shown in this figure, and more details on this integration are available in the Enhancing Data Loss Prevention with Integrations module later in this course. This figure shows how to configure the encrypt response action for data discovered on file servers. First, select Network Protect Encrypt File, and then click Add Action. The response action will require no further configuration, and after you name the role, click Save and apply the response rule to one or more policies that apply to scans. This figure shows how to configure the encrypt response action for data discovered on SharePoint servers. First, select All, Server FlexResponse, and then click Add Action. Select SharePoint Encrypt as the plugin, and after naming the rule, click Save and add the response rule to one or more policies that apply to SharePoint scans. After creating the appropriate response rules and adding them to relevant policies, you must configure the scan targets to execute the responses. To do this, in Enforce, go to Manage, Discover Scanning, Discover Targets, and then create a file system or SharePoint scan target. Click on the Protect tab and select the actions for which you have already configured response rules. For file system targets, you can choose Copy, Encrypt, and/or Quarantine. For SharePoint targets, you can choose Quarantine. Note that encrypting files on SharePoint is accomplished using a server FlexResponse rule, and therefore is not configured in the target. You need to designate the quarantine copy share path by typing the file server path using the universal naming convention for file servers, for instance, //servername/share, or the URL for SharePoint servers. For authentication, you need to specify the credentials with write access to the quarantine copy location. The protect credentials, which need write access, are required to move or delete the target file and leave a file marker in its place. The content of the marker file is configurable and helps ensure that business processes are protected and that employees receive education on security policies. Advanced configuration for file system scans for replacing a confidential file with a marker is controlled within the protectremediation.properties file. This file is accessible by navigating to the following location shown on this slide for either Windows or Linux. You can choose the following parameters. The com.vantu.protect.onedirectory/per-scan parameter is configured based on your need to retain the original folder structure of each relocated file. The value can be true if you want to create a new directory in the quarantine share for each scan, or false to use a single directory and version the file by appending the scan information to the file name. The com.vantu.protect.extensionsNotReplaced parameter allows you to add any number of extensions separated by a pipe symbol, where the file marker will retain the extension and its corresponding icon. Only by viewing the reduced file size and opening the marker can a user determine if the file has been replaced. If nothing else is listed here, the file marker extension is .txt. Note that marker text is only added to files that can be opened in Windows Notepad. Other file types will get a .txt appended to the replaced file name. The FlexResponse platform enables you to protect data with manual or automatic actions for custom remediation. If you choose manual remediation using smart response rules, you can perform the remediation actions from Network Discover reports. Alternately, you can create automated response rules to perform the remediation actions automatically. With the FlexResponse platform, you can perform a range of Network Protect remediation actions, such as quarantine, copy, application of digital rights, and encryption. Symantec DLP provides FlexResponse plugins to perform automated and on-demand copy, quarantine, and release from quarantine actions. The SharePoint Recovery FlexResponse plugin for Network Protect extends release from quarantine capabilities to SharePoint sites. For this FlexResponse plugin and rule, the Network Discover target definition must have write access for both the quarantine location and the original location of the document in order to release the SharePoint documents from quarantine. The installation process and requirements for the SharePoint Release from Quarantine FlexResponse rule are documented in the Symantec Data Loss Prevention SharePoint Quarantine FlexResponse Plugin Implementation Guide, found on the support.symantec.com website. Symantec DLP Endpoint Discover can scan thousands of agents to proactively identify information that, as defined by policy, should either be protected or not stored on endpoints. Endpoint Quarantine can remove confidential content from these exposed locations to a secured repository on the network, for instance, or even locally using a managed folder not accessible to the end user. Additionally, customers who integrate Symantec DLP with Symantec Information-Centric Tagging, or ICT, can apply ICT classification tags to confidential files identified during Endpoint Discover scans. Finally, there is an Endpoint FlexResponse rule that can use custom plugins to take custom actions on confidential data identified in Endpoint Discover scans. This section will discuss all of these response actions, starting with Endpoint Quarantine. This figure shown here demonstrates the process to set up Endpoint Quarantine. First, set up the quarantine location, configure the quarantine credentials, if needed, configure the response rule and associate it with one or more policies, and then configure the endpoint scan. You can create an automated response rule that allows Endpoint Discover policies to remove files from a local drive and place them in a secure folder. If an Endpoint Discover scan finds a file containing sensitive data, the file is quarantined and removed from the non-secure location. Use the Quarantine Path option to enter the path to the secured location where you want the files to be placed. The secure location can either be on the local drive of the endpoint computer, or it can be on a remote file share. The quarantine location can either be a secured folder on the local drive, or a folder on a remote file share that is connected to the endpoint computer through the corporate network. If you choose to have the quarantined file sent to a remote file share, you must specify whether to allow anonymous access or use specific credentials to allow access. Anonymous access lets the Symantec DLP agent impersonate the local system to move the confidential files to the secure location. A specific credential lets the DLP agent impersonate the specified user to access the remote file share. If your secure location is on the endpoint computer, no credentials will be needed. If you combine or use multiple endpoint response rules in a single policy, ensure that the order of precedence for such rules is clearly defined. The endpoint quarantine location is defined per response rule and not per scan. You can also create marker files that replace the confidential data. The marker file alerts endpoint users that the file contains confidential information and was quarantined. You can also specify the location of the secure folder in the marker text. You must add credentials to the credential store before you can access credentials for the Endpoint Discover Quarantine Response rule. The credentials are stored in an encrypted folder on all endpoint computers that are connected to an endpoint server. Because all endpoint computers store the credentials, care must be taken regarding the type of credentials that are stored. Use credentials that cannot access other areas of the system. To create endpoint credentials, first configure the setting Allow Saved Credentials on Endpoint Agents under System, Settings, General, Credential Management. Next, navigate to System, Settings, Credentials, and select Add Credential. Under the General section, enter the details of the credential that you want to add. Under Usage Permission, select Servers and Endpoint Agents. Customers who integrate Symantec DLP with Symantec Information-Centric Tagging, or ICT, can apply ICT classification tags to confidential files identified during an Endpoint Discover scan. This figure shows the high-level steps for configuring the integration and creating the response rules. First, configure the Enforce to ICT connection, install ICT agents on all appropriate endpoints, import the tag taxonomies from ICT to Enforce, and then configure response rules. For more details on this integration, please see the Enhancing Data Loss Prevention with Integrations module later in this course. You can create an automated response rule that causes the ICT agent to add classification tags to confidential files. If an Endpoint Discover scan finds a file containing sensitive data, the ICT agent adds the tag specified in the Endpoint Discover response rule. Configuration of the Endpoint ICT classification and tagging response action is shown in this figure. Note that for Endpoint Discover, the Alert and User Override options in the Endpoint ICT Classification and Tagging Response Rule do not apply, so you should leave these deselected and blank. These options apply to use cases in which ICT requests DLP to identify confidential data and to specify the tags that the ICT agent then applies to email and saved files. For more details on these use cases, please see Symantec's ICT product documentation. In addition to the Endpoint Quarantine and Endpoint ICT Classification and Tagging Response Rules, the Endpoint FlexResponse technology is also available for performing remediation of Endpoint Discover incidents. For instance, a customized FlexResponse plugin can be developed to encrypt, redact confidential information, or adjust the permissions of a file with sensitive information. As discussed earlier in the module, the Symantec DLP solution integrates with Symantec's CASB solution, CloudSOC, in order to provide comprehensive protection to data that is flowing to and from or is stored on a supported cloud application. In addition, Symantec DLP Cloud Storage provides the ability to scan box cloud storage accounts. In this section of the training, we will focus on data at rest, so we will cover how cloud storage and the integration of DLP and CloudSOC can inspect this data and take action on it based on your DLP policies. For the integration of DLP and CloudSOC, such policies are applied to a CloudSOC securelet, CloudSOC's name for its mechanism for scanning data at rest, through an application detection configuration that you create in the Enforce console. To use the DLP and CloudSOC integration, customers must purchase a license for DLP Cloud Detection Service, the DLP component that integrates with and performs detection for CloudSOC. Some use cases for extending DLP policies to cloud storage and collaboration sites and services are shown in this figure. Symantec DLP Cloud Storage Discover supports scanning and protecting confidential files residing in box cloud storage. Options for protective action are 1. Applying a visual tag to sensitive files, and 2. Quarantining confidential files. For the quarantine response, files are moved from their original location and quarantined in either a controlled box repository or an on-premise CIFS folder. Similar to the functionality for file systems, marker files can be optionally left behind in place of the quarantined item. The process for configuring protective actions on cloud storage in box is shown in this figure. First, the cloud storage scan is started, and the detection server will crawl and analyze all the content in box. The cloud storage detection server will then quarantine files that violate policy, either within box or an on-premise folder. To configure this protective action, you will need to enable the quarantine option in a particular cloud storage target. The list of targets is available in Enforce at Manage, Discover Scanning, Discover Targets. When you define a cloud storage target, configure the proper parameters for the quarantine action, namely the folder that will be used for quarantine, as well as the required credentials. The configuration is sent to the cloud storage detection server, and when a scan finds a file that triggers an incident, the detection server initiates the proper actions on the file. The option to allow quarantine protect remediation must be selected for cloud storage quarantine response rules to be executed for this target. As shown in this screenshot, there are 2 options for the quarantine location: in box, in the co-admin user's box folder hierarchy, or another specified box user, or in a CIFS file share, most likely to an on-premise share whose details have been specified. The Enable All Tag Response Rules when Scanning option enables the Add Visual Tag Response Rule action that can apply visual tags as metadata to sensitive content stored in your box cloud storage target. The Cloud Storage Add Visual Tag Response Rule helps your box users search for and self-remedy cases of sensitive data residing on the platform. Once Cloud Storage discovers a file that contains information protected in DLP policies, Symantec DLP adds a visual marker to the file in box, as configured in the response rule. This screenshot shown here presents an example of this response rule. Note that the metadata is not embedded in the file itself, but it adds a visual marker to the list of files displayed in box. The second screenshot at the bottom of this figure shows an example of an item that has been tagged by Symantec DLP Cloud Storage, as displayed in box. The Cloud Storage Quarantine action deletes a file from the original path and moves it to the defined quarantine location, whether in the cloud or on-premise. A marker file can optionally be uploaded in place of the original file, similar to the network protect actions discussed earlier. This is configured when you create the response rule, as shown in this screenshot. A unique characteristic of this feature is that it also creates a metadata XML file alongside the quarantine file. The XML facilitates future recovery actions. You will notice that there are many more action options available to you when you are scanning data at rest on cloud applications, and only some of these examples will be discussed in this module. These options can include quarantining, removing shared links, and encrypting when DLP is integrated with ICE. Some additional DLP response rules for CloudSOC data at rest can include preventing the downloading, copying, or printing of confidential files. You can also control collaboration access on files by defining the collaboration level as either read, preview, or edit. You can also control other aspects of the file access by defining access to the confidential documents as being either all read, or internal edit. Note that there are two broad categories of action that can be taken: action on the file containing the confidential data, or action on the application permissions for the file containing the confidential data, or both. As will be discussed in more detail later in the lesson, you will note that not all of the functionality available in Enforce as an action can necessarily be applied to all supported securelets. Before launching into configuring response rules, it is useful to remember the steps that are necessary to complete prior to the services working as they ought. It should be remembered, for instance, that this functionality is an integration with Symantec CloudSOC and can only be achieved through the use of the Cloud Detection Service. The Cloud Detection Service must be configured and Enforce. Additionally, the DLP functionality must be provisioned on the CloudSOC infrastructure. This step is taken in the CloudSOC UI. While in this UI, you must also enable the relevant securelets. It should be noted at this point that there may appear to be more securelets available in CloudSOC than are supported for DLP, and this is normal. CloudSOC performs more than one function, and CloudSOC's development cycle will differ from DLP's development cycle. When you configure this functionality, you are effectively authorizing CloudSOC to inspect the content of a repository. Therefore, it is necessary for there to be an official relationship between the provider of the target application and you. CloudSOC can't be configured to scan the content of an employee's personal box account, for instance, although this traffic can still be captured while it's in motion on your network, of course. CloudSOC can scan an employee's corporate box account. As a result, depending on the securelet that you are configuring, more information may be required to complete the configuration in CloudSOC, although the level of detail will vary on the application itself. Once configured, however, there are no further steps to take in CloudSOC, and no configuration to take on the user's endpoint, as this is not scanning traffic in motion. It is worth noting that you can have multiple corporate accounts for any given securelet, say if you have an existing relationship with a provider, and then purchase a company that also has a relationship. Once the configuration has been completed, you must create some response rules which will take action on any confidential data found in cloud applications. First, navigate to Manage, Policies, Response Rules, and create a new rule. Complete the fields in the General section at the top of the screen. Optionally, in the Conditions section, from the first drop-down, select Incident Type. Then from the third drop-down that appears on the right, select Cloud Applications and API Appliance. This can help keep order to the rules and what they achieve within your policy set. Finally, from the Actions drop-down, scroll down to the Data at Rest responses. There are two sections here. One lists the actions that can be taken on the file itself, and the other looks at how the data can be accessed, viewed, or edited from within the application. Note that both file actions and access actions can be taken on the application. Next, you must create an application detection configuration for each securelet which you are looking to protect data on, depending on what other rules you apply. To do so, first, in the General section of the configuration, ensure that the policy has a name, the type is securelet, an application is selected, and that you have identified one or more policy groups to apply to the configuration. Next, select the appropriate configuration in the Rules section if this is not going to be a blanket policy applicable to all content residing on the application. For the Exposure Type field, you can select some combination of internal, external, or public exposures. And additionally, you can specify whether you want to find any file that matches one of the exposure types, or files that match all specified exposure types. For instance, selecting both the internal and public exposure types and then clicking Match Any would result in a policy which would trigger when files that are either internal or public are matched, whereas selecting Match All would match only files that are both internally and publicly exposed. Using the Users and Groups field, you can choose to apply the SecureLit policy to specific groups of users or to everybody except a specific group of users. For the Folder Paths option, you can identify specific locations or whether all traffic to the configured destination should be scanned. You can also add file properties, specifics that are based on file extensions and/or file size. This figure shows a conceptual overview of how Enforce, Cloud Detection Service, and CloudSOC communicate together. First, CloudSOC will scan the content of configured SecureLits against the rules specified in the application detection configuration. Next, documents matching the parameters sent to Cloud Detection Service will be checked against policy groups listed in the application detection configuration. If a policy is matched, the Cloud Detection Service will create an incident and send the information to Enforce, and then the action to take on the content will be sent to CloudSOC. Actions dictated by the response rule or smart response will be taken on the matching content. Afterwards, subsequent scans will scan new or altered content unless a rescan of the repository is manually selected from the CloudSOC UI, for instance if a new policy is added or an existing one edited. To review, Symantec DLP can help organizations protect data at rest from becoming data at risk due to undesirable or unintended exposure, broken business processes, or loose access control lists. Symantec DLP provides response rules to perform data cleanup of CIFS file systems, SharePoint, and Box. Endpoint discover scans performed by the DLP agent can protect information locally stored on endpoints. Further product integrations allow you to encrypt confidential data when it is found on endpoints or elsewhere in the network by leveraging Symantec's Information-Centric Encryption, or ICE. Plugins developed using the FlexResponse framework extend out-of-the-box protection options for data at rest. And additional cloud data at rest use cases are available with the integration of Symantec DLP in Symantec CloudSOC through the use of the Cloud Detection Service. To review, this module explored the technology that Symantec DLP offers to protect data in motion, data in use, and data at rest. First, we reviewed how response rules work. We explained the difference between automated and smart response rules. The former are executed immediately after an incident has been detected, according to given conditions, while the latter can be invoked by authorized incident responders on demand. This first topic also detailed the best practices related to the order in which response rules are invoked. In the second topic, you learned how Symantec DLP can protect confidential data in motion by integrating with network egress point technologies, such as mail transfer agents, web proxies, and through the use of the Cloud Detection Service Symantec's CASB CloudSOC, as well as its cloud-hosted web proxy WSS. These powerful integrations not only let you prevent the exposure of sensitive data, but also help you confidently embrace the benefits of cloud solutions. Symantec's Network Prevent for email, Cloud Prevent for Office 365, and Cloud Services for email offerings can stop email data loss by blocking messages in real time with customized alerts for users and administrators. Additionally, by modifying RFC 2822 message headers and integrating with MTA and encryption gateways, such as Symantec Messaging Gateway, Symantec Gateway Email Encryption, and Symantec Email Security.cloud, you can accomplish powerful and flexible protection, such as encryption, redirection, and quarantine. Lastly, Symantec Network Prevent for Web can instruct web proxies to block HTTP, HTTPS, and FTP communications, or it can remove the confidential data from the transmission for complex Web 2.0 applications. The next topic covered the available options to secure confidential data at the endpoint. We emphasized how to configure the proper response rules to achieve your security goals. Symantec DLP Endpoint Prevent can notify, for awareness and education purposes, empower the end user to decide if an action should proceed through the user cancel option, or block a forbidden action. This last option can combine a notification pop-up window, or it can be done silently. When a notification window is presented as the result of an endpoint incident, Symantec DLP offers users additional options to capture the reason of a given action, which can be a critical success factor to understand future awareness needs. FlexResponse technology can also be leveraged to accommodate customized actions to perform incident remediation. The last topic, Protect Confidential Data at Rest, discussed how Symantec DLP can help you apply proactive controls to protect information in place, perform data cleanup, quarantine, and move information to more restricted repositories. It also covered how, through integration with CloudSOC, additional cloud repositories could be inspected and have DLP policies applied to the content. The topic presented the response rules that Symantec DLP delivers out of the box, as well as some examples of FlexResponse plugins. Here are some links to relevant reference material. Also note that you can access the full knowledge base and help support material at the support.symantec.com website. Thank you for joining us. This concludes the Preventing Unauthorized Exposure of Confidential Data module of the Symantec Data Loss Prevention 15.5 Administration course.